Lesson 8.4 is our last section of hypothesis testing. We're going to be talking about t-test. So the t-test is used for two sets of quantitative data that are measuring the same thing. It only applies to normally distributed data. Even though we haven't talked about normal distributions yet, we'll be talking about that next chapter. We're just going to assume everything they give us is already normally distributed. So you're comparing two types of data. For example, the first example we're going to be looking at is tulips that are growing in two different areas and seeing if there's a difference between their heights. So you're comparing the means of this data. So the null hypothesis is always going to be that there's no difference, so that the means are the same. So this notation here, remember back from a couple chapters ago, this means the mean of the first group is equal to the mean of the second group. Your alternative hypothesis depends on what type of t-test you're doing. There's two types, the two-tailed t-test, which you're just looking to see if they're equal or they're not equal. So the alternative hypothesis for a two-tailed t-test would just be that the two means are unequal. A one-tailed t-test, you're specifically looking to see if one mean is less than or greater than the other one. So your alternative hypothesis would be that, whichever way you're looking at it, one mean is greater than or one mean is less than the other mean. So this first example, Maisie noticed that the sun shines more on one side of her garden than the other side, and she wanted to know whether this had any effect on the heights of the tulips. So she's just looking to see if there's any effect, not necessarily that one is bigger than the other. So this is going to be a two-tailed t-test, just that the means are different. So she measured the 20 tulips from each side of her garden, and here is the data here. So first thing, go ahead and pause the video and write down your null and alternative hypotheses based on a two-tailed t-test. So for a two-tailed t-test, the null hypothesis is that the mean's the same. That's true no matter what your t-test is. And then your alternative hypothesis is just that the mean heights are going to be different. So now we want to find our t-value and our p-value. So again, I'll show you how to do this in class, but the way we're going to do it is you're going to go into Stat and Edit, and L1 and L2 are going to be your two lists. And then you're going to go to Stat, Test, and you're going to go down to number 4. We're always going to use this one, the two-sample t-test. You want your input to have data highlighted. List 1 should be L1, list 2 should be L2. And for this one, since we're doing a two-tailed t-test, you want the mean of the first one to not equal the mean of the second one. That's going to change depending on what type of t-test we're doing. And then you want pooled to have yes highlighted. So go ahead and try that and find your t-value and your p-value. So if you do all this, you should end up with a t-value of negative 3.07. That's similar to like your chi-squared test statistic, but this is our t-test statistic. And then our p-value is 0.00392. So this is the same thing as our chi-squared test for independence and goodness of fit. This is our probability value, and you compare it to your significance level the same way. For a t-test, we mostly use a 5% significance level, but you can use 1% or 10% like we do for chi-squared. So now that we have our p-value, compare that to our alpha level and comment on our result. So just the same as our chi-squared test, in this case we don't have a critical value, so we're just looking at our p-value compared to our alpha level. So for our p-value of 0.00392 is less than our significance or our threshold of 5%. So therefore we're going to reject our null hypothesis. There is a difference between the mean heights. So the heights on the left side of the garden are statistically different than the heights of the tulips on the right side of the garden. Here's a second example. Mr. Arthur gives his two chemistry groups the same test, and he wants to find whether there is any difference. Again, any difference, so now we're looking at a two-tailed test. We just want to see if the means are the same or the means are different between the achievement levels of the two groups. Here's the results. Notice that the two groups don't have the same number of data points. That's okay. For t-tests, you don't have to have equal length lists. So given this data, go ahead and do your t-test. So write down the null and alternative hypothesis, use your graphing calculator to find the t and the p-values, and then given a 5% significance level, decide on whether or not there's a significance difference. So for part A, whenever you have a t-test, your null hypothesis is always going to just be that the mean grades are the same. This is a two-tailed t-test, so your alternative hypothesis is that the mean grades are different. So for part B, find the t-value and the p-value. So following the steps that we used in the previous example with our graphing calculator, we find that our t-value is negative 0.235 and our probability value is 0.816. So if you haven't already done so, go ahead and pause the video and use the fact that our alpha level is 5% to state a conclusion for the test. So our p-value is 0.816, which is greater than our alpha level of 0.05, so therefore we are not going to reject our null hypothesis. So given the data that we have, we can assume statistically the mean grades of the two different groups are the same. So our last example, an oil company claims to have developed a fuel that will increase the distance traveled for every liter of fuel. This is not a typo. This is how internationally they spell liter. 10 scooters are filled with 1 liter of the normal or the original fuel, and 10 scooters are filled with 1 liter of the new fuel, and the distances are written out. So now we're not looking to see if there's a difference. We are looking to see if there's a difference, but we want to be more specific than that. So this is going to be a one-tail test. We're looking to see if the new fuel has a greater mean for distance traveled than the old fuel. So given the fact that this is now a one-tailed t-test, go ahead and pause the video and write down your null and alternative hypotheses. So the null hypothesis for any t-test is always the same, so the mean distances traveled are the same. In this case, because it's a one-tailed t-test, our alternative hypothesis is going to be slightly different. We're going to be more specific than just that they're different. We want to know whether the original mean is less than the new mean. So our x sub 1 bar less than our x sub 2 bar, because this is going to be our first list here. So now given that, we want to find our t-value and our p-value. So for a one-tailed t-test, you go through all the same steps that we did for our two-tailed t-test. The only difference is where it asks for mu1, originally we were saying is not equal to mu2. Now we want mu1 to be less than mu2. So make sure you highlight this one when you go to do your t-test. So go ahead and pause the video and do parts B and C. Find out whether or not there's a statistical difference. So using our graphing calculator, we find that the t-value is negative 2.83 and the p-value is 0.0056. So just like before, we're going to compare that to our 5% significance level, or alpha is equal to 0.05. So p is 0.00561, and that is less than our 5% threshold here. So we're going to reject our null hypothesis. So therefore, the company's claim is correct. The mean of the old fuel is less than the mean of the new fuel. So just a brief review of the 3 hypothesis tests that we looked at. We talked about the chi-squared test for independence. So are the two variables given independent of each other? We also looked at the chi-squared goodness of fit test. Does the data collected match whatever the given distribution that we're looking at is? And then today we talked about the t-test. So are the mean values of your data equal, or if it's a two-tailed t-test, are they not equal? If it's a one-tailed t-test, is one greater than or less than the other? So this has been hypothesis testing.